Hello, coming to you from Daytona State College. It's Dr. Ron England again, and this time we're going to talk about something incredibly interesting, equal payment series. So what exactly is an equal payment series? Well, the reality of the world is when you borrow money, you don't pay it all back at one time. When you invest, you can invest in different pieces, different amounts at specific times, or most of the time it's just an equal payment. So typically, if you're doing a mortgage or a car loan, it's going to be an equal payment on a monthly basis, an annual basis, whatever. Okay, equal payment series. So these things exist, and therefore we can actually use them for equivalence. Because remember, when we're comparing options, we want to get to the equivalent amount of money. So, compound amount factor. Well, this is relatively simple. This looks like a complex slide. Reality is it isn't. You got these payments, okay? Each one of those can be put as a future value or a present value. They can all go to a value that is at a specific point in time, okay? So you could take each individual payment and then calculate its value at a common point in time, and that would give you the compound amount. So let's look at this. Now, first, let's look at what, this is an important thing, concept of an annuity, because you need to know the term annuity. So a typical annuity would be something like a fixed sum of money paid to somebody or a thing or a business for a period of time, rest of the life. The definition of annuity itself means it's paid to someone. Okay, so you have an annuity of $1,000, or you have that's paid to you from something like that. You can put an annuity into your will. Basically says, I got all this money. Instead of them inheriting it all at once, they can do it as an annuity. Okay, or an investment that pays out. So there's a lot of different ways, but really it is a series. Boom, 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 boom. Pieces of money that are paid on a regular basis. Now, let's take this and put it together into an equation. So, if you are looking at the value of a payment series that's paid on a regular basis, okay, once a month, once a year, again, the equation is right here. The future value is the annuity, or the amount right there of each of the individual payments. And I'm not going to read the rest of the equation because you can see it. It's 1 plus I to the n minus 1 over the I. So if you want to play with calculating this, and you should be able to calculate it, just plug in the numbers on this one, 5,000 over 5 years at 6%, find the future value. Now, what is this? Future value of an annuity is looking at it like if you're looking at two of them that you want to do as an equivalent, you're taking that annuity and the equivalent future value, the amount that it's worth at a future time, is that value. They're the same thing. Okay? Straightforward. Remember, equivalence is your friend. Whenever you're looking at amounts of money, whether it's an equal payment series or a value or an investment at a specific point in time, and you want to compare, you need to bring everything to an equal point in time. All right, to validate it, okay, that equation that we just showed you, we can do the exact same thing simply by adding up all the individual amounts and see if the value, the money, comes out the same, which it will, by the way, okay? By just using the equation we had in the last lecture, the basic compound interest equation, which you know because you've memorized it, right? You have. All right, so how do you find the value of the annuity itself, the amount of money that's in the equal payments? Well, you simply solve for A. It's that simple. You can solve for F, which is the future value. You can solve for A, which is the annuity. Okay? And remember, the annuity is simply an equal series of numbers that are payments or amounts dispersed over time. Okay? Again, don't complicate. This isn't that complex. These are the ways that you deal with money. Equal payments, a value at the tail end, which is the future value, a value at the beginning end, which is the present value. So here's a situation that can occur. Okay, handling time shifts in a uniform series. I just wanted you to be prepared for this one. Again, not incredibly complex. The problem here is that you have a deposit at 0, but you don't have a deposit at time 5. So the equation doesn't apply. Now, you can always calculate this by looking at the value of each of those individual payments at either the future value. You could also do it at the present value at the beginning, but that's the value at F is simply the compound interest equation. So just take each individual amount and then put them together and then add them all up, and you're going to get a value. So going back and forth between those, you can say, okay, so I can't use the other equation. Well, the reality is you can use it. I'm going to show you how you can use it. But you can always just take each individual value and shift them over to time equals 5 and do it that way. Again, this shouldn't be complex because it's just the simple compound interest equation applied to each of those individuals and putting it at time F, at future value. Okay. Now, another way you can do it is actually to use the equation, the annuity equation here, calculate it for all 6 of the payments. There isn't a payment in the last year, but calculate all 6 of them, and then subtract out the last one because the last one occurs at the final F. So therefore, it is the value at that time doesn't have to be adjusted. It's 5,000. So you subtract the last one out, which is the 5,000 you subtract out. So if you do all 6, you're going to get $34,876.59. And if you subtract out the last one, you get $29,876.59. Shouldn't surprise you. It was the same value you got by doing all of them. Okay, again, this is just a way to do where you don't have to do every single payment with the one equation. But again, they're both going to give you the same answer. What are we doing? We're taking a series and we're looking at it as an equivalent amount at the end, future value. Now, beauty of this is that you've got a lot of these functions built into spreadsheets. Why use a spreadsheet? Because you may have a lot of calculations to do. And, truthfully put, this is kind of hard to do on a calculator, putting all these together. It's not the easiest calculation to do. So you have financial calculations built into Excel. So what I want you to do is I want you to go into a spreadsheet, Excel, and I'm pretty sure it's in Google Sheets, even though I haven't tried it with Google Sheets, but you've also got some of the calculations in there. I also do these because there's some great financial packages built into Python, and I do a lot of work inside of Python programming. I teach the programming for engineers, which I actually have you do these types of calculations in that class. So, in the case of the problem that you have here, if you use the FV, okay, you go and you pick the function out of the Excel financial calculations, and you put in all the numbers, you get the answer. Now, to ensure that you know how you're doing this, here's what I want you to do. Calculate it, well, by hand, I would say with a calculator, and then calculate it with Excel, with the functions, or build the equation in Excel itself. Build the equations up. Okay, the last one that I showed you, I just simply typed in the equation. Okay, I didn't use one of the Excel equations, and I just manipulated the spreadsheet. You should be capable of manipulating spreadsheets well. This is a great opportunity to practice it. And you got some ones that you know the answers of. So another one that you can do with Excel, saying, okay, well now we know a present value, we've got an annuity, we've got I equals 7. Okay, what is that annuity amount? Let's see. And again, you can calculate through using the Excel to find the A from the present value, not the future value. But that begs the question. We just did future values. Okay, we've also got the ability to look at present values. The Excel calculation will let you calculate the rate, and it'll let you calculate the future value, it'll let you calculate the annuity. Hey, they're all in there. Okay, that's pretty nice. So in Excel, First, look at the Excel and look at the different things that they have in the Excel functions, the financial functions that are available to you, and the way that they call them. Present value, you should now understand. Future value, you should now understand. Equal sum series, you should now understand. Number of periods, you should now understand. And compound interest rate, you should now understand. Realize that we're not doing things with simple interest rate very much anymore. Okay, so to find some of these, you're going to use specific functions. And these are the functions that you can use to get that value from the other ones. So like present value, KPV, okay, you use the PV function with the rate, and per payment FE, the other values. Okay, it's not that hard. So again, more important is that you understand how these things work and what are you actually doing. You're finding equivalencies. You're finding that an amount, a series of payments, can be equivalent to a value at the beginning of a period or at the end of a period. They're the same based on an interest rate. Now, that factor inside the brackets, where you see A equals F and the I over I plus 1 to the N minus 1, that's called the sinking fund factor. Not sure where that name came from. I'm not really caring a whole lot where that name came from, but it's the sinking fund factor. So if you were to do, hey, I need to do this and calculate A using the sinking fund factor, okay, it's relatively straightforward. In this case, if you're looking for the A, which is the series, okay, the PMT function will let you do that. That's the function in Excel, and you can get it using the built-in Excel function, or you can use the equation directly. Just calculate it. Use a calculator, or again, type the equation into Excel. When typing the equation into Excel, you might want to test the equation, because once you've written the equation, you can use it with all sorts of different values. But test it with these values and see if it actually is working correctly for you. Now, another factor that you might hear is capital recovery factor. Okay, so in this case, you see that there's the future value is in that equation that uses the sinking funds factor. It's A equals F times the factor. A is the series of payments. F is the future value, but also F is equal to the present value, 1 plus I to the N. So if you replace that, and remember, that's the simple compound interest equation. If you use that and you substitute that in, now you've got the series in terms of the present value. So we can look at the series, we can look at the present value, and we can look at the future value, and you've got a way to calculate all three of them, remembering that the two variables that you deal with are the interest rate and the number of periods. Again, it's that straightforward. If you've got interest rate and number of periods are really the conversion factors between series, present, and future of money, and each of them can be, if you put them all into one terms, then you've got equivalency of what that money is in one of those different, either A, P, or F. So now, just putting it into a definition that I'm kind of hoping you all can understand is a capital recovery factor is a ratio that determines the present value of a series of equal cash payments. So what you're really saying is that it's got the equivalency between present value and equal cash payments. It's the factor that lets you convert from one to the other. Remembering that capital recovery factor is a function of I and N, interest rate and number of periods. Okay, capital recovery factor, okay, boom, we've just done that one. I want to remind you of this because we're going to go one step further. Simple calculation. I'm not going to go through the numbers of this. This is for you to sit in front of this computer while I'm watching this video, plug in the numbers in Excel, and see if you get the same answer by doing it two ways. One, putting the equation in, Other one, using the actual built-in Excel functions, because you need to know both. Okay? And things that occur, okay, such like a deferred loan repayment plan. Well, how do you do this? Like in this case, there's a grace period of a year. It's like, okay, we're going to push everything back. Oh, this is, we're going to buy some furniture, and you don't make any payments until the year 2029, or, whatever. Okay, it's still a time series, still got a present value, a future value, and this is a series, so you got all of those. All you do is you shift to a time, in this case time 1, and use your equation. Now you got the value at time 1, which you can easily slide over to time 0, because that's just simply the compound interest equation to go over. You've got a value that you need to shift in time. Everybody should be able to do that with the compound interest equation, which you know by heart, right? You do. Good. Glad to hear that you do. Now, present worth of an annuity series is just looking at it and solving for the next thing. So present worth of an annuity series is P equals A, and there's your equation. 1 plus I over the n minus 1 over I. Okay. Yes, it's a long equation. Here's some numbers. You can play with it and make sure that it works. Again, put it in Excel. Put that equation in Excel and test it with these numbers. If it works with these numbers, with a cell that has I and N, you got it. You know it's going to work. Now, capital recovery factor. Okay, present worth of an annuity is the inverse of the capital recovery factor. They're just the inverse of each other. That's it. And I think that the easier one to remember is the present worth of an annuity. I think it's pretty straightforward when you say the present worth of an annuity. Well, that's an annuity, that's A. Present worth, that's P. And then there's a factor that gives you that, okay? Yeah, pretty straightforward. Again, I'm going to give you one here. Straightforward. These are the numbers. Play with it and see if you can get your numbers to match my numbers. Okay, and again, I think at this point here, it's probably pretty smart to do all these in Excel. Now, here's something interesting. Sometimes you've got plans to make a certain amount of money sometime in the future, like a retirement plan or a deferred savings plan or an early savings plan or any savings plan. You want to put money into something because at some point in the future you want a certain amount of money. Retirement plan is a very good example of these. Now, in different savings plans, you can either put money in early, you can put money in late, or you can put money in all the time. Now note, in these two savings plans, between time 0 and 10, you're putting in $2,000. Let's look and see what it's worth at time 44. In the other option, you start at 10 and you go to 44, which means that you're putting in stuff, $2,000 for 34 years. You're going to be putting in, the first plan you put in for 10 years, the second plan you put in for 34 years. What happens when you do this? Okay, well, you can calculate these. Now, you can calculate these two different ways. I've shown you two ways to do it. One is just take those individual values, calculate their future value at a specific point in time and add them all up. Or you can do of the annuity, because there is an annuity there that's in a specific point in time, get the value at the end of the annuity period and then move that forward in time to 44 using the compound interest equation, because you've got the value at a specific point in time. You've got the annuity, figure it out at time 10. It's 34 years to 44. Simple compound interest equation will get you there. Okay, bottom line is, in this case, the early savings plan has a value of $396,645. Okay, $2,000 a period for 10 years. Now, do the same thing with the deferred savings plan, but realize you're doing it for 34 years. Note, it has less money than the early savings plan. That should give you an idea of how time value of money is important to you. Okay, you had to put in money for, in this case, 34 years to get less money than you put in for 10 years here. Okay, now, another thing that you can solve for, and this is just a good hypothetical, at what interest rate would these two options be equivalent? Well, really what we're going to do here is do all these, we're going to set up a spreadsheet, do the calculations, and get the future value of each of the two options. And the target cell that you see in here, if you can see it, is the difference of the two, $79,392.61. So what I'm going to do is I'm going to tell you that there's a way in Excel to get that target cell to 0. And you can get it by changing any value in that spreadsheet. Well, the value that I asked you to do was the equivalent interest rate. So basically what you're saying is that the interest rate is high, those early options should be better. And if the interest rate is lower, the deferred savings plan should be equivalently better. So what I would expect to happen is if I wanted to make each of these plans equivalent, the interest rate needs to be lower than 8%. Because right now, the early savings plan is better than the deferred savings plan. But as the interest rate goes down, the deferred savings plan should become better. Why? Because the interest of all that early investment compounds up very nicely. And there's a way to do this. So, goal seek. And goal seek works like this. And I'm going to let you play with it and figure it out. There's plenty of good instructions there. But goal seek is this. You have a cell that you want to get to a target. So if I go back to the spreadsheet that I had there, I want to get the target cell to 0. That's the difference between the future value of both options. I do that by changing the interest rate. And when I do that, it's going to get to an interest rate of 6.5, and then the target cell is going to end up being 0. And guess what? It did what we expected to do. It went down. Okay? All right. You can calculate it other ways too, but you know what? That works. Now, that should be, it's not magic. All we did, we now have 3 things to play with. We have annuities or series of payments. We can call them, if I call them an annuity, if I call it a series of payment, I'm still saying the same thing. Really, the difference is where the money's going up or the money's going down, but it's the same thing. There's a future value, which is at the end of a period. There's a present value, which is at the beginning of the period. And you can calculate the value of anything at any point in time as an equivalence. And you can move that equivalence back and forth in time. Now, you're going to do some problems with that. You're going to play with it. Everybody should have a good understanding of how all these pieces work. Okay, now you're becoming financial wizards. Guess what? We've got to start dealing with some other things like, oh my God, inflation, because it affects it. Taxes, okay, well, inflation's easier to deal with because that's a number that we always know. We can actually put into some equations. It does get more complex. But these right here, get a good solid understanding of this. It really isn't that hard. So calculating all these great financial things just made me hungry. I'm going to go eat some tacos. On out.